Let's dive into the PKCE flow proof key for code exchange flow. As mentioned in the last lesson, PKCE is an extension of the authorization code flow. So essentially we have the same flow as before, but with an additional layer of security, the proof key for code exchange. But what exactly is this proof key for code exchange? The OAuth 2 client starts by generating a random string, which ranges between 43 and 128 characters. Next, the client hashes the string using a hash algorithm. The recommended standard for PKCE is SHA-256. This process results in a hash value. Afterward, the client encodes this hash value, giving us an encoded hash value. In PKCE, the random string is called the code verifier. The encoded hash value is called the code challenge, and the hashing algorithm used is called the code challenge method. If we have the code verifier and the code challenge method, we can generate the code challenge. And this is exactly the core of PKCE, the proof key for code exchange. It's important to note that PKCE supports a blame method without hashing. In this case, the code challenge is simply the same as code verifier. Although this method is less secure and typically discouraged, it exists for legacy clients or for situations where hashing is not possible. Now let's explore how the PKCE flow works. Since we already have a solid understanding of the authorization code flow, we can jump directly into the sequence diagram and see how the PKCE flow adds security. We have the same familiar players: the resource owner, the user agent, the client application, the authorization server, and the resource server. The cool thing about PKCE is that it supports both public clients and confidential clients. This makes it suitable for a wide range of applications, including browser-based applications, native mobile applications, desktop applications, and even traditional server-side applications. The resource owner initiates the flow by attempting to log in or granting permission to the client for accessing the resources. The client generates a PKCE, which includes the code verifier and code challenge. It stores the code verifier locally in memory or another secure location. The client then redirects the resource owner to the authorization server's authorized endpoint, similar to the standard authorization code flow. However, here is the key difference. In addition to the standard query parameters like client ID, response type, code, and redirect URI, the client also includes the code challenge and code challenge method in the request. The authorization server stores the code challenge and code challenge method. The resource owner authenticates with the authorization server and, if applicable, reviews and approves the requested scopes. After successful authentication, the authorization server generates an authorization code and redirects the resource owner back to the client, along with the authorization code and state as query parameters in the URL, just like in the regular authorization code flow. The client sends now a post request to the token endpoint of the authorization server to exchange the authorization code for an access token. There are here two key differences compared to the authorization code flow. The first key difference is that in the PKCE flow, sending the client credentials such as the client secret is optional for public clients, but required for confidential clients. The second key difference is that the client also includes the code verifier that was generated and stored earlier. This verifies the client's identity when exchanging the authorization code. The authorization server validates the authorization code and the code verifier and, if applicable, the client credentials. To validate the PKCE, the server uses the stored code challenge and code challenge method. By applying the code challenge method to the code verifier, the server can generate the same code challenge and confirm that the exchange is legitimate. If everything checks out, the authorization server responds with an access token and possibly a refresh token, depending on the server's configuration. Finally, the client uses the access token to request resources from the resource server on behalf of the resource owner. The resource server validates the access token and, if valid, returns the requested resources to the client, completing the process.